Hello friends, welcome to our channel Knowledge Amplifier. So in this video I am going to discuss about interquartile range. This particular concept, whatever I am going to show you, plays a very important role in understanding different statistics of data in a summarized way. Okay, in any data science project, this box plot what I am going to show you next is going to be very important. But before moving forward, we should have concept of IQR or interquartile range. So in simple words, let me discuss what is the concept, statistical concept behind box plot. So first of all, suppose I have one data set 2, 4, 4, 5, 6, 7, 8. Now what is median? I hope you all know what is median. It is nothing but the value. If you sort the data set, take the middle value, that is nothing but median. That is one particular value which is present in your data set, which is basically separating the higher half of the data from the lower half. Okay, that is called median, right? Like here 2, 4, 4, 5, 6, 7, 8. It is already sorted. So middle element is 5. See, this particular data is separating the lower half from the upper half. Okay, so this is called the median. Okay, this particular part is lower half, this particular part is upper half. Okay, now you consider only the lower half, that is 2, 4, 4. Now what is the median for this lower half only? Consider this lower half as original data set. So the median is obviously going to be 4. So basically this 4, this element is going to divide the lower half into two parts. So this is called quartile 1 or Q1. Okay, so Q1 basically what it does, it basically divides the lower half of our original data set into two parts. One is lower part, another one is upper part. Okay, so in the overall data set, if you consider, you can simply understand median is dividing here in this side 50%, in this lower side 50%. Then Q1 is dividing here for this lower data set, if you consider as whole. So Q1, this one is dividing basically 50%, 50%, right, for this lower half data set. So if you consider the whole data set, Q1 is basically in the left side of Q1 there is 25% of data, in the right hand side there is basically 75% of data. As simple as that, right? So similarly, in the upper half, if you consider 6, 7, 8, 7 is dividing the upper half into 50-50. So this is called Q3, or you can say like this is right median, Q1 is left median, Q2 is global median. Although these are not statistical terms properly used, but you can interpret like this, right? So this is what about quartile 1, quartile 2 and quartile 3. And the difference in between Q3 and Q1 is called interquartile range. Okay, this is the simple concept. So median is our data set, median is our point which is dividing our data set into 50-50. Now try to understand this figure and keep in mind, because this is summarizing the whole concept. It may look confusing, but it is very simple. See, Q2 or median is basically dividing our whole data set into left side 50%, right side 50%, right? And then Q1 comes, it divides the left side data to 50-50. Similarly, Q3 is dividing the right side data or upper side data into 50-50, right? In the overall data, if you consider, in the left side of Q1 actually only 25% of data is present, right? Because this 50% is nothing but 50% of only the left side. The left side is basically half of our whole data set. So basically this 50% is nothing but 25% of whole data set, right? And Q3, right side of Q3, there is 50%. This 50% is nothing but 50% of our only upper side. And the upper side is 50% of whole data set. So in the right part of Q3, actually only 25% of whole data is coming, right? So in the right of Q3, 25% of data, in the left of Q1, 25% of data. So in between Q3 and Q1, the amount of data which is present is 50%. Okay, so in the interquartile range part, the amount of data is present is 50%. Okay, remember this. And coming to box plot, there is the plot looks like this. This summarizes the whole concept. Okay, what is that? See, you will be getting something like this: horizontal straight line, then vertical straight line, then one box shape, then again one horizontal line, then one vertical line, then one horizontal line, right? See, remember this, in the box, in the middle part, you will see one line. That is basically median of our data set. The lower part of the box is basically Q1 or which is basically 25% of data. Okay, Q3 is upper part of the box which is basically indicating 75% of data, and this one are basically mean and max. Ideally it should be mean and max of our whole data set, but practically it is not. I will discuss what is present in this mean and max, but before going to that, let me just discuss the Matlab function. The Matlab inbuilt function is box plot. Okay, it has a central mark. The central box part is basically, if you consider, there will be one central mark which is basically denoting the median. Bottom and top edge part of the box is basically indicating 25th and 75th percentile, and whisker is nothing but this particular straight line, vertical straight lines are called whisker. Okay, so this particular plot also called as box whisker plot because box and whisker combined. Okay, so most extreme data point not considered as outlier. Okay, so what is that? This particular max or mean, whatever we are calculating, we are ignoring outlier and then we are considering. Okay, not considering outlier because outliers are like data set which is basically differing from rest of our data set by a huge amount. So while calculating this max or mean, we are not considering those outliers. Okay, keep this in mind. Now, how to detect outlier? Already I have discussed. Different methods are there. Method of Z-score is present. Then median absolute deviation method, using that we can detect outlier. Different techniques are there. So whatever mean and max we are calculating, this is not actual mean and max of our whole data set. This is ignoring outlier because outlier, suppose in positive direction outlier is present, so that should be the max, right? Because outlier is very high value in the positive side, but we are not considering while calculating this max for this box plot. Okay, so this is not actual mean or max of our data set. This is ignoring the outlier, and in the box plot itself we plot outlier using the plus symbol. Okay, so this is what is the box plot. So this is the reason why this is called box whisker plot, because combining one box and some this kind of vertical extended parts are present which are whisker. Okay, and this box is nothing but, see what I told you, lower is Q1, upper part is Q3. So this box is nothing but indicating interquartile range. Okay, and this particular box plot summarizes many statistics. See, you can get the idea of median, quartiles, okay, 25th and 75th percentile, minimum, max, ignoring outlier, and obviously outlier also using the plus symbol you can get. So there is a huge importance of this box plot. The how to interpret data distribution from box plot I am going to discuss in my next video, but for the time being I just wanted to give you the fundamental idea of IQR, what is 25th and 75th percentile, what is box plot, what is whisker, what is mean and max, why that is not global mean or max. All these things I hope it is clear to you. Okay, and how to calculate this outlier using this particular interquartile range. There is one formula. These two formula you can keep in mind because this is many times widely used in data analysis related projects. Okay, higher outliers are those outliers which are basically more than Q3 plus 1.5 into IQ1. Okay, Q3 is what? 75th percentile. We are adding 1.5 of IQR with that. If any particular value present in our data set is more than that also, then we'll consider that as higher outlier. And for lower outlier, just replace the plus by minus, and instead of Q3 we'll be taking Q1 because lower outlier will present below with respect to this particular Q1 in the below side, right? So we'll subtract this value. So lower outlier is nothing but Q1 minus 1.5 into IQ1. Okay, lower out, if one data point has to be lower outlier, then it should be lesser than this one. Okay, Q1 minus 1.5 into IQ1, right? So for our higher outlier, it should be greater than Q3 plus 1.5 into IQR. For lower outlier, or for any data set to be considered as outlier in the lower direction, it should be lesser than Q1 minus 1.5 into IQR. As simple as that, right? Now what we can do, we can go to Matlab and do some plotting. Okay, so see here I have taken one simple data set, CLC, clear all, close all, winding off, x equal to 22, 25, 17, 19, 33, 64, 23, 17, 20, 18. Okay, so first let us try to calculate manually what are different parameters of my box plot. Okay, so first sort the data set, because to calculate the median, 25th percentile, 75th percentile, we require to sort our data set, right? So first I have sorted. Let us see the sorted data set. You can clearly understand that our median is going to be what? See, 1 2 3 4 5 6 7 8 9 10 10 data points. Cool. So for middle data will be these two, you will be considering 20 and 22. 20 plus 22 by 2 is 21. So the median for this data set is 21, or else you can simply check median of x, you will be getting 21, right? So 21 is dividing our data set into lower and upper half. Lower half is going to be obviously below 21, that is 17, 17, 18, 19, 20, and upper half is going to be 22, 23, 25, 33, 64. Okay, cool. Now consider the lower half, which is this one, 17, 17, 18, 19, 20. Now you tell me what is the median for this lower half. That will be obviously 25th percentile or Q1 quartile 1, and that is nothing but 18, because 18 is the middle value for this sorted data lower part, right? Similarly, can you tell me what is the Q3, that is median for the upper side of the data set? See, upper side of the data set is this one. You can clearly understand median value is 25. Okay, cool. So Q3 is 25, Q1 is 18. What we got, right? So what will be IQR? IQR, interquartile range, will be Q3 minus Q1, which is basically 7 in this case. Okay, now how to consider outlier? See, positive outlier. Okay, positive outlier present in our data set is nothing but Q3 should be, if positive outlier is present, then that should be greater than, okay, Q3 plus 1.5 into IQR. Okay, right? So we can give here logical indexing. So our data set is x greater than. Okay, so if any value of x is greater than this particular calculated value, that will be considered as positive outlier. See, we are getting one logical array, and see this one index we are getting as 1. What is this index? This is 1 2 3 4 5 6. At 6th index, outlier, positive outlier is present. Let us check in our data set. See, x 1 2 3 4 5 6. See, 64. You can clearly understand 64 is far away with respect to our other data set. So 64 is positive outlier. Now it's time for negative outlier. Let's check negative. Okay, negative. Negative outlier should be x less than, any data set present in our x should be less than Q1 minus of 1.5 into IQR, and see, you are getting 0, all 0. That means no negative outlier is present in our data set. So what we are concluding, for this data set Q3 is 25, for this data set Q1 is 18, interquartile range is 7, positive outlier is present, and that is our 64. Okay, no negative outlier is present. Now how to plot, how to get all the statistical measurement in a single plot? See, the command is box plot of x. So I am just running these simple lines, and see, we are getting this kind of plot. Okay, see what I have told you, box plot, one box will be there and two whisker, two extended part in the upper and lower side is present. Okay, the central mark is basically indicating the median of our data set. What was our median calculated? 21. See, if I just give grid on, it will be, I guess, better. Now let us run. See, here this particular mark is 20, little bit above of that this central mark is coming, which is basically median. We have calculated median as 21, and see, you are getting that it is 21 only, right? Or else if you want, you can go to tools and then from tools you can go to data cursor and place your data cursor here. Okay, see clearly median is 21, it is showing from here also. Okay, cool. Then our, let me close this and run this once more. Then next comes our this one, upper part of our box, that is 75th percentile of our data set. Okay, which is basically 25. We have calculated Q3 as 25. This one lower edge, this is nothing but Q1 or 25th percentile, which is 18. Okay, below 20 you can understand that this is near to 18, right? Then this one is maximum but ignoring outliers. This one is minimum of our data set ignoring negative outliers, like that. Okay, but where outlier is present, see this one plus symbol you are getting right here, this is basically indicating outlier. So from a single graph we are getting many information. Okay, median, 25th percentile, 75th percentile, mean and max ignoring outliers, and outlier, if outlier is present, that idea also we are getting from our box plot, right? Then some more interpretation we can get, simply write box plot of x comma notch on. Okay, if you just write notch on, what will happen, you will be getting same graph like earlier, but here in the central part there one notch will come. You can understand in the median part. Okay, like one belt has been surrounded the box. Okay, that is coming like this. So this is notch on parameter does this. Just no extra statistical information we are getting, just different representation. Then box plot orientation horizontal. Okay, this will tilt our box plot and show horizontally, and you can apply both notch on orientation horizontal also. So if I just run all this, so same thing we'll be getting in different plot, just little bit change in the visualization. See, this is our original box plot, same graph with the notch in the central part, right? Same graph of as of one, this one we are getting, just it is horizontally we are plotting, and like this one, see these two are same only, just horizontally plotted, right? So this is what about our box plot. Now generally in machine learning or data science related project, our data is not going to be array, it is like one matrix format where or table format where some independent features are there, we need to apply statistical measurement and do data analysis on that, right? So if you just check box plot documentation, you can clearly understand it creates box plot of our data. If x is a vector, like I have shown you in this explanation, here I have considered as vector or one single array. Okay, box plot plots one box. Okay, if x is a matrix, okay, like a table, okay, generally what we deal with in data science project, box plot plots one box for each column of x. Okay, so for each independent feature you will be getting one different box plots, so no need to worry about anything. Okay, one more feature of box plot I want to show you. Suppose one income dataset is present and another column is present as gender. Okay, gender is male and female. Okay, now with respect to male, you want to group your dataset. Whatever male is present, for that corresponding income you want to plot one box plot, and for female dataset you want to plot a separate box plot. So this kind of grouping also can be done in Matlab. See this second description, box plot x comma g creates a box plot using one or more grouping variable containing in g. Okay, so g is basically storing our grouping variable based on what we are going to group our data x. Okay, and it is going to plot different box plot for different groups. Okay, for this I can show you one simple demonstration. See here, first let me write CLC clear all, close all, warning off. Okay, so now if you just check this particular dataset car small, this is present in Matlab database itself. So first what I will do, I will import the dataset. See, initially my workspace is empty. Now as soon as I click on this evaluate selection part, including the load card small, all these data came into workspace. Okay, now see, if you just observe the MPG, it is having numerical dataset, okay, with some nan values obviously. And if you check the origin, this is basically one categorical data, okay, USA, Japan, Italy, different country name is present. So suppose what we want to plot the box plot of MPG, this numerical data, based on grouping of Germany, USA, country wise. Okay, that is for the Germany, whatever MPG data is present, for that only one box plot. For Italy, whatever data is present, for that another box plot. Like that, if you want to plot, simple idea, what you do, you just write box plot of MPG, that is our X, for which we want to compute box plot based on, or grouping based on origin, okay, grouping based on country. Okay, so if I just run, you can see simply what it will do, it will plot box plot for different country. USA one box plot, France another box plot, Japan another box plot, Germany another box plot, Sweden another box plot, Italy another. Okay, so like this it is working. Okay, right? So grouping can be done on data like matrix format, whatever we generally handle in data science. How we can plot box plot, that also I have discussed. And what is the simple intuition, or how you can understand this box plot, what is what, this is median, this upper part is Q3, this lower part is Q1, this is minimum and this is maximum, ignoring positive and negative outlier. If outlier is present, how is outlier detected? Okay, that is Q3 plus of 1.5 into IQR. If any data point is more than that, that will be considered as positive outlier. If any data point is lower than Q1 minus 1.5 into IQR, that will be considered as negative outlier. If outlier is present, that will be shown like this kind of plus symbol. All these things, I hope it is clear to you. This is all for this video. In my next video, I will be discussing some more concept related to box plot. Thank you for watching.